Okay, our final speaker of the morning session is Stephen Palmer, Emeritus Professor at UC Berkeley. He will speak about contextual fit as a determinant of aesthetics, and I'd like to note that he will be, his works of art will be on display tomorrow night during the reception, so definitely come take a look. Thanks, Stephen.
Thank you. Thank you. Yeah, this is good level. I want to thank the organizers for inviting me. This is kind of a perfect sort of meeting for me, since I spent about 40 years studying visual perception at Berkeley, and during the last 10 or 15 years, I tried to sort of found a new field called aesthetic science. I didn't really succeed, but since retiring now, I've slid sideways into art. I'm an artist, and as she said, my art will be up tomorrow night. I want to call your attention to a change, that the authorship of this presentation now includes one of my close collaborators, Karen Schloss. I realized as I was putting this together that I did almost all of this work in collaboration with Karen. So Karen, would you stand up, please? Everything that's wrong with the talk, of course, is due to me, and everything that's right is due to Karen. So the plan for my talk includes a number of parts. First of all, I want to talk about this idea of aesthetic science, what it is. Then I'm going to talk about some evidence that aesthetic science is possible through the research that we've done together. First, talking about color preferences and something called the ecological valence theory of color preferences. Then I'm going to talk about color preferences in a musical context and show how people's color preferences change depending on what the use of those colors is going to be. And then I'm going to talk about why there might be the kinds of associations that we have between music and color, and actually make an argument that is fundamentally mediated by emotion. And if I have time, and I'm sure I won't, I might talk at the end about individual differences in an aesthetic dimension that we call preference for good fit. So first of all, aesthetic science, what is it? It's hard to find a good definition. Here's a simple one: the study of the mind and emotions in relation to the sense of beauty. But of course, what is the sense of beauty? And that doesn't really get you very far. So for me, and in my research, aesthetics is actually a dimension of human experience that goes from ugh yuck to oh wow. So this is going to be a dimension that is going to be part of our response to almost everything, but most centrally things like painting and photography. Those are actually my photographs. But even mundane things like home decor, landscapes and travel destinations, or eye candy, what you like to look at in terms of people. And the fundamental idea is that aesthetic response happens all the time to everything. Most of our aesthetic responses are pretty neutral. It's like this room, you know. You go into a Hyatt Regency and you, oh wow, you know, it really hits you. So, but in everyday choices, like for example, whether you're going to put flowers on the dinner table and where you're going to put them, whether you want to drive to where you're going through the faster or the more scenic route, whether you want to wear a hat on a bad hair day, or whether and you go to a restaurant, you're going to sit facing the street or facing the garden. Those are all aesthetic choices. So fundamentally, I'm claiming that we have aesthetic responses all the time to everything. Sometimes they're extreme and we notice them one way or the other. but most of the time they're actually not. And I want to make sure that you understand that when I say aesthetic science, I'm not talking about the psychology of art. Art is a kind of object that has been created for a specific purpose, probably related to aesthetics, but there are all kinds of things that are aesthetically pleasing or unpleasing that are not works of art because they're the objects themselves. And until somebody paints them or takes a picture or something like that, it's not an aesthetic object. I also want to mention that for me, preference is primary, aesthetic preference is primary, because although there are lots of factors that are part of aesthetics, the reason that I think they're part of aesthetics is because they project, they influence what it is your preferences are. So for example, things like familiarity and symmetry and who the artist is and knowledge about the genre of painting or whatever, that's all part of it, but it's presumably, from my perspective anyway, it's part of it because it influences your preferences for things. Do you like them better or not, depending on whether they're familiar or not. Now there's lots of different approaches that you can take to aesthetics. The most typical one, I would say, is what I call a normative approach. And this is where so-called experts, who are artists or art critics or whatever, who try to tell you what it is that you should like. This is a great painting, and they'll tell you why it's a great painting and so forth. That's not what I'm interested in, and that's not part of what I call a scientific approach to aesthetics. But there still are plenty of things to look at. One of them is an empirical approach in which you produce a descriptive analysis in which you find out what people actually do like. You collect data, right? And that becomes the foundation for your aesthetic science. And then also theoretical approaches where you try to explain why it is that people like those things or that color in the case that I'm going to be talking about. I keep putting this picture up because this is one of my early what I consider to be aesthetic achievements. Is a photograph that I used Photoshop's watercolor filter on because I thought it should be a watercolor painting. Is what I wanted to capture when I took the photograph, but it doesn't look like that in a photograph. But with the changes in color and texture and so forth that you can make with the watercolor filter, in fact, it becomes much more like a painting. And I actually brought this with me, so you can see that tomorrow night. Now, a lot of people will tell you that aesthetic science is not possible because science is objective and aesthetics is subjective, and science is lawful and aesthetics is whimsical. And we have these phrases like there's no accounting for taste and beauty is in the mind of the beholder, which are all often stated in service of the idea that a science of aesthetics would be impossible. And I want to claim that that's not true, and I want to claim that, let's just say, this talk is intended as an existence proof of aesthetic science in terms of descriptive and explanatory approaches. So I'm going to first talk about color preferences, and this is the way that we study color preferences. We show people a color on a calibrated computer monitor, and we ask them to make ratings of various different features. For example, how much do you like this color? And we use a slider scale where people move the slider along the scale and they click on the point that corresponds to how much they like it between not at all and very much. We other times will ask them, how happy is this color? And they make a slider rating. It's not at all happy, it's very happy. How angry is this color, and so forth and so on. These are all just subjective ratings. This is a way of getting data on these subjective dimensions of aesthetic response. So in the studies that we did of color experience, we had to sample colors. And I was actually hoping that Brian was going to talk about color appearance spaces of the sort that we use, but he didn't. There are lower level and higher level color appearance scales and spaces, and he was talking about some of the lower level ones. The one that we actually used is one called the natural color system, or we used a system like that. in which the color dimensions are a hue, which is a circular dimension. It has two components, a redness-greenness component and a blueness-yellowness component. And then there's a dimension, a radial dimension of saturation going from the center outward, which denotes the vividness of the color, also sometimes called chroma. And finally, lightness, which is the light to dark from black to white. And these are all represented in this color space that looks like a sort of double ice cream cone. The colors that we actually studied the preferences of are 32 colors. We call these the 32 BCP, the Berkeley Color Project colors. And we use 8 hues, which consist of something close to the 4 so-called unique hues of red, green, blue, and yellow. These are the sort of pure colors that are, I'm not going to go into that. And another 8 hues that are sort of midway between those, orange, purple, cyan, and chartreuse. And for those who are not, so this is chartreuse, is a yellow-green, and cyan is a blue-green. And then we sample those colors at 4 different, what we call, cuts through this color space. The saturated colors, which are the ones around the outside, the most vivid versions of those colors. A set of colors, the light colors, which are about halfway between the saturated colors and white at the top. The muted colors, which are halfway between the saturated colors and neutral gray in the middle. And the dark colors, which are halfway between the saturated colors and black at the bottom. So this is just a sort of systematic way of sampling a reasonable number of colors in order to get a fairly reasonable approximation of what kinds of color preferences people have. Now, it could be that this is too coarse a scaling, but when we've looked at, if you average over observers, you typically find things are pretty smooth in between. That's not necessarily true for individuals. So this just shows you what the colors look like when they're all displayed on a neutral gray background and when they're projected onto a particular color space. So what did we find out when we measure these colors in this way? Here's a function, this is a preference function for the light colors, and what you can see is that there's a preference for the cool colors around blue. People have a dispreference for the warmer colors, but there's a bump there at yellow, which actually I maybe have something to say about later on. And when you look at the muted colors, it's pretty much the same. Not very big differences there. When you look at the saturated colors, it's a similarly shaped function. It's just that people tend to like saturated colors more than they like the muted and the light colors, the desaturated colors. The interesting thing happens when you look at the dark colors. The dark colors the shape is different in the sense that the dark warm colors, essentially the dark oranges and the dark yellows are in fact very much disliked, okay? But the dark greens and the dark reds are very much liked. So this is kind of funny from a color space, color perspective, because you would sort of expect all these colors to have essentially the same kind of shape. If you thought it was based on something like cone of contrast or even the kind of color space that we selected our colors from. But you can make a pretty interesting little story about this, and this is what the story that we told when we first got these data, that actually you can explain sort of which colors people like most and least in terms of things like, well, they like saturated blues because it's the color of clear sky and clean water, and light blue-greens because it's the color of swimming pools, and dark and saturated green is the color of vegetation and fresh fruit. But these colors that are not so much liked are in fact objects that are kind of yucky. I call this color, this dark yellow, I call that color yucky poo. So you can tell this story, but is it true? I mean, and we really felt like we were compelled to try to test that hypothesis. And I'll say, just for the record, I didn't want that to be true. I wanted it to be some function of like cone contrast, or I wanted it to be like psychophysical, because in this phase of my career, I was kind of moving toward like psychophysical kinds of, trying to discover psychophysical kinds of relationships. So we figured out a way to do, well, I should get ahead. So you can have different kinds of theories about why you get the preferences you do. A biological theory that based on cone contrast that was presented by Herbert Ling and a number, there's just something about the excitations of different cone contrasts, representations in the early visual system that for whatever reason are more or less liked. That's possible. But my driving notion became an ecological approach. And the idea is, so what are preferences for? What do we have, what sense does it make to have preferences? Well, preferences are sort of a biological or ecological steering mechanism for an organism. And if you think about like food preferences, what kind of foods do we tend to like? We like things that are sweet and fatty, and we don't like things that are bitter and sour. Well, what's that about? Well, there's a correlation between the nutritive value of different kinds of things that we might eat, that things that are sweet and fatty give us calories and tend not to be noxious, and things that are bitter and sour tend to be poisonous or noxious in ways. So if you let your taste buds tell you what you should and shouldn't swallow, you actually do pretty well. It's a biologically plausible thing to do. So with that as background, so suppose you just translate that into color. Maybe there are correlations between the colors that good things are versus bad things are, that if you sort of go toward the good colored things and away from the bad colored things, that you'd actually be pretty well off. And that's the presumption of the ecological theory. There can be both, and I presume there are both some genetic components that sort of start the system out and a learning that takes them into the future. So we decided to fit some linear models, and I shouldn't say we did because Herbert Ling did it for us. So we looked at the percent of variance that we could account for using that cone contrast type theory, the biological theory. And you can actually measure the percentage of variance, but even with all three of those systems, you only get 34% of the variance, which is not very much. The question is, how well can you do with the ecological valence theory? All right? So, but we have to figure out how we're going to measure that. How are we going to test that? So this is a complicated experiment. I want you to listen up because there's 4 different groups that we have to test and then combine the results in particular ways. So the first group I've already told you about, and that is we get a group of subjects to rate each of the 32 colors in terms of how much they like them, preference. Then we get a second group, independent group of subjects. They see the same set of 32 colors, and for each color, we ask them to write down a brief verbal description of all the things they can think of that are that color. So for this blue-green, they would say swimming pool, tropical ocean, fish tank, et cetera, et cetera, et cetera. And in fact, then we have to sort of compress this to get to a reasonable sized list, and we compressed it down to 222 object associations. Then we get a third group who comes in, and we just give them the verbal labels of the object associations and ask them to rate the valences. How much do you like those things? How much do you like tropical oceans? How much do you like fish tanks? How much do you like swimming pools, etc.? And then we get a fourth group to come in, and they're asked to rate the match between the object descriptions and the colors so that were given for this. So here we show them the blue patch that elicited the description of tropical ocean, and we say, how good a match is this? From very good to not very good. And we're doing this because, undergraduates come into these things. We don't even know, I don't think we even look to see whether these guys had good color vision. They're going to give you some very strange matches, and you want to downweight those when you do this calculation that we're going to talk about. So we're going to calculate something called the WAVE, which stands for the weighted affective valence estimate for a given color. So we're going to take this blue-green example, and we have this list of all the objects that people have said that are this color. And we have a list of all the valences. These are the average liking ratings of all of those things when they were given as text. And we've got these match scores, which we're going to use as sort of weighting function, and we're going to multiply the match scores, the weights times the valences. So it's going to upweight the things that are really good matches. It's going to downweight the things that are really bad matches. And you'll see the things like, for example, clear sky has a very high number because it's both very much light and there's a pretty good match. And when you multiply those things together, you get a pretty high number, as opposed to somebody thought that forests were this color. Like I said, undergraduates will tell you almost anything. But even though people generally are pretty positive toward forests, it's not a good match, so it's going to be downweighted. Yeah?
Can you quickly just explain the range of valence and how participants report it?
It goes from, for the valences, how much do you like it? It goes from I really don't like it to I really do like it along one of these line mark rating scales.
Yeah, so I'm just looking at the values and trying to figure out.
-200 to +200.
Oh, what is the, okay. She said the
And the
right
match is
thing.
from 0 to 1.
How did they get above 100? Yes, okay. So then we take calculate the average of these values in the third column, and for this color we get a score of plus. So from all of this work, we get one number for one color, right? But notice that all of these numbers are positive because it goes from +200 to -200. And in fact, when you have things like vomit or whatever, people give those very negative ratings as well. So not all of them are, in fact, this color is one of the very few in which basically everything is positive. So what do we find out? Those are our color preferences. That's what we measured. And then we can calculate, we've got a wave value for each of those colors, and we can plot those. And that's what it looks like. And in fact, the correlation between these two things is almost 0.9. And you can see that the things that are most liked and the things that are least liked are essentially the same across these two, the data set and the model. Now notice that we've accounted here for 80% of the variance with no estimated parameters. I mean, there's a bazillion actual sort of theoretical parameters underlying this model, but we've estimated them all by doing these procedures, like saying, well, how much do you like these things, what colors, what objects are this color, and so forth. So in terms of the linear models, we've got the cone contrast, which accounts for 34% of the variance, and the waves, which account for 80% of the variance. I leave it to you which one you think is better performs. Now we've done experiments with this ecological valence theory in a lot of different contexts. So we've shown, for example, by looking at studying Berkeley students and Stanford students and their color preferences as a function of how much school spirit they have for Berkeley or Stanford, and find out that Berkeley students like blue and yellow much more than Stanford students do, and the Stanford students like red and white. And this is in a context where there's no reason to believe that they thought that we were asking about Stanford colors or Berkeley's colors. It was in the context of all of these things. But one of the things we looked at was individual differences. So one of the things that, I don't have a slide to show this, but you can believe it, I'm sure from your own experience, that different people like different colors. And the question is, can you actually predict different people's color preferences better if you actually compute a wave for that particular person as opposed to another person? So you can do the experiment, the wave experiment, instead of having 4 different groups of subjects, you can use the same group of subjects where they all give you the data on all of those things. And if you like broccoli and you give a high number to broccoli, then the prediction of the wave of the ecological variance theory is that you're going to tend to like the dark green or saturated green more than somebody who hates broccoli. I mean, that's the fundamental idea. So the way that we did this, operationalized it, is, that you can have different color preferences if for the same objects you have different valences. You like stuff, somebody else doesn't like it. Or if you have objects that they don't know about, that they don't have any valences for. So the prediction is fundamentally that, averaged across people, the predictions for my own wave will fit my own color preferences better than the waves from other people. So we compute the wave for person I and person J, and the preferences for person I and person J, and then we look at the data in this kind of matrix where subject 1, you've got the wave on the left-hand side and the preference on the right-hand side. The main diagonal corresponds to the within subject preferences, correlations, and the others correspond to the between subject preferences. And you find out that there's a pretty big difference between the correlation for people's own wave versus other people's wave. So this is showing that this ecological valence theory is not only accounting for average color preferences, it's accounting for a reasonable amount of individual color preferences. Now you'll note that this correlation within subjects is only about 0.6, right? So it's better than for the between subjects, but it's not as high as the overall average across all people, which was 0.89, sorry. But still, you can account for some of this variance that way, okay? So now I'm going to show you that not only are there individual differences in color preferences, but the color preferences that you get can depend radically on the particular context. And the context we studied, and I'm going to talk about in detail later on, is a musical context. So what we did was brought participants in and we asked them to imagine that they were color consultants and that they were going to listen to some music of 4 different bands and make recommendations of what colors there should be on the album covers for these 4 bands. The colors we picked were not the unique hues, but these in-between ones: saturated orange, chartreuse, cyan, and purple. And we had 2 harmonious bands. We called them Peace, which was really Celine Dion, which was really Enya. And 2 dissonant bands that we called Chaos, which was really Skinyard, and Friction, which was really Slipknot. So to give you an idea of what these sounded like, you probably know what Enya sounds like. So just think about which colors you would pick for the album, for Enya's album, or rather, sorry, for Unity's album. Okay, and then here's Friction. So would you pick the same colors for those 2 album covers? Well, our subjects said no. We actually had them make 2 alternative forced choice judgments. So they saw 2 colors and said, which of these 2 colors would you rather have for this kind of music, for this music? And then we also later had people make a second kind of judgment, which is how well does this music fit? How well does this color fit this music? So first of all, I want to show you that for the harmonious bands and the dissonant bands, the correlation between people's color preferences they were essentially opposite. I mean, the correlation is like minus 9.97 or something like that. And the second kind of rating, minus 0.95. The second kind of rating were these goodness of fit. How well does this color fit with the music of this band? And we got essentially something very similar in that the goodness of fit ratings were also very negatively correlated with each other. But the correlation between the preference and goodness of fit judgments was plus 0.97. So it looks like people are somehow their preferences are fitting their goodness of fit ratings very well. We also tested pair preferences, color pairs, not individual colors. So these were particular pairs of colors, some of which were highly harmonious. For example, blue on blue and purple, and some of which were highly disharmonious, purple and chartreuse and orange and cyan. And once again, when you look at people's preferences ratings for the dissonant music versus the harmonious music, they're essentially opposite each other. And when we ask them to make the fit ratings, they're also opposite to each other, but they are very highly correlated with each other. So the point of this experiment is that color preferences can change radically, by which I mean they can go from one extreme to the other depending on the context. And there's something about music and color. There seems to be some kind of notion of what things are good fitting colors for different kinds of music. And the question is why? And that's the fourth topic I'm going to talk about. So music and color. So this became a fairly important focus in our laboratory research. And it started with an experiment where we were looking at classical orchestral music, which is the music that I kind of know best and I thought would be an appropriate place to start. And we would play people music, and then we would show them this array of colors and say, and we actually said, pick the 3 colors in order that go best with this music. And I'll give you an example I'll play. So, and we had, 18 different pieces of music. So 6 by Bach, 6 by Mozart, 6 by Brahms, all orchestral. And we structured it according to, there's a major piece and a minor piece, these are short excerpts, and a slow, a medium, fast. So we use tempo and major versus minor mode for each of these 3 composers. So I'm going to do the Bach for you of the biggest contrast, just so you get the idea. So here's the fast major Bach. Which colors would you, so just which color do you think is the best color for this? And here's a Bach slow minor. Which color goes best with this music? Okay, now those are actually, that's a really nice contrast because it's not only Bach, but it's actually from the same piece and it's played by the same orchestra or the same chamber ensemble, and it's sort of like everything is the same except the music itself, and those particular features, tempo and major versus minor, seem to be particularly important. Okay, so we also had them pick the colors that went worst with it, but you don't need to really know that. These are the data. Okay, I love showing this slide. These are the data. So this is showing you the first pick for the best fitting colors for each of these Bach pieces. So I played you the major fast and the minor slow, and you can see, you just look and see that those colors are not the same. And in fact, the ones that are slower and more minor are darker and bluer and less vivid, that is more gray. And the ones that are faster and major are lighter and yellower and more saturated. And we can quantify these things. That was for a small sample of subjects that we had come into the laboratory. Since we're able to do this with the collaboration of Nautilus, which is an online magazine, to collect data on 33,600 whatever participants, they did the same experiment that I just explained to you. These are the same 2 pieces, and now we've put together these enormous amounts of data so that the area that's contained by the different color corresponds to the number of people who pick those colors. And you can see again that these data are very much, these are lighter, more saturated, yellower colors that are picked here. These are darker, grayer, and less saturated colors. And you can see these colors that are picked all the time up here are very, very seldom picked down here. And these colors that are picked very frequently up here are not picked very often up there. So that's my only foray into big data.
Can I ask a question?
Yeah.
Go back for a second. Do you keep track to the same people who picked the wrong colors at the top?
Not in
pick wrong
this.
colors?
We haven't actually analyzed these data anymore from this or not. But
I just wanna
if I get to the end topic on individual differences and preference for harmony, then there may be something to say that's relevant to that. Okay, so why is it that people systematically pick different colors to go with different music? And our notion was what we call the emotional mediation hypothesis. The idea is that when you listen to the music, you have some kind of an emotional response. I don't know whether you actually feel those emotions or you just perceive that those emotions are relevant or something. But then the idea is that you pick the colors that have common emotion with the music. In order to test that hypothesis, we have to collect some extra data on the emotional associations of each color and the emotional associations of each piece of music. Yeah?
When you have them pick colors, do you have them pick it in this formation that you have here? Like that's the picture?
Yeah, we do. We do use this, either this or something that's inverted, so that the stuff at the top is at the bottom and the second and the left is the right.
Have you ever thought about like including the colors around? So
Yeah, we have. The problem is that when you're having people do this experiment, if they want, to find the color that you want, it's pretty important to have it be systematic so that they can find the colors. Now, anybody who wants to can redo this experiment with random colors, and I'm pretty sure that it's going to come out almost exactly the same. But you could do it that way to find out whether there was some influence. But it's not just that lighter things are at top versus bottom or something like that, because you can reverse them and it doesn't matter. So then we collect these data, we give people a color and an emotion and say, well, for this color, how happy is this color? And they use that slider scale, like I said before, how weak is this color, how lively is this color, and so forth, to get these emotional ratings. And for the music, we do a similar kind of thing. So I can even play it for you. So how happy is this music? How weak is it? How lively is it? And similarly for the other pieces, how happy is this music? Et cetera, et cetera. All right, so what do we find? So what we're going to plot here is, we're going to plot how happy versus sad is the music, and how happy versus sad are the colors that go with this music. And we're looking for correlations, right? So, happy versus sad is 0.97. I mean, I've been in the business for 45 years and I've never seen a correlation like that. And this is the flakiest experiment I ever did. I mean, most people when I describe this experiment, they think, oh, what's going on? What's wrong with Palmer? He's going off this rocker. You're never going to get anything from that. But not so. So happy versus sad is correlated 0.97, the color and the emotional response. Lively, dreary is 0.99, strong, weak is 0.96, and angry, calm is only 0.89. What a disappointment. The conclusion, wowzers, right? This knocked my socks off. And to show that it really is emotion, and I'm not going to go into this really at all, I thought I might have been following Rousseau's presentation, which was about music and emotion, but you rearranged things. So we picked some other stimuli that have a natural emotional interpretation, which are faces. If this emotional mediation hypothesis is correct, you should not only have mediation of color music matches, but also color face matches and face music matches, also that are mediated by emotion. So the way that this sort of goes is you have a bunch of pictures of different emotional faces that you get. I don't want to say how you get them. And then you ask, how well does this face go with this color? You show them the color of the face and you get them to. And in fact, when you do that, you get similar kinds of results, 0.97, 0.793, and 0.91. So this is more evidence for the emotional mediation. Okay, 5 minutes. All right, so I think this is pretty interesting. It makes a certain amount of sense that it might be emotionally mediated. We wanted to be good experimental psychologists, so we did a follow-up experiment in which we just used single-line piano melodies that were based on Mozart, where you can actually there's nothing different between one melody and the other melody except it's a minor version of the major melody, or it's played faster, or it's played slower, or it's played in a higher octave or a lower octave. And we did the same kind of experiment, got the same kind of results. The correlations were all like in the 0.9s and 0.8s. Then we went in the other direction, and this is the most recent stuff, where we used 34 different genres of music. And so this sort of shows you the kind of range that we used here. Some of it, lots of pop versions of various kinds of music. So I'll play you some representative things. So here's some Hindustani sitar music. Here's some 80s pop. Ghana. What else would you like to hear? Bluegrass. How about bluegrass? All right. How about some classic rock? Okay. So they're doing the same task for all these different kinds of music. This is the other end. We did the good experimental psychology where we crushed the variance out of it, so it was exactly nothing except the tempo and mode and pitch height. And now we're going the other direction. We're sort of taking all comers, 34 different kinds of music, and we get the emotional associations the same way we did before, and we get for the music and so forth. I'm trying to get, so here the first choice data, again, huge differences. Look at the heavy metal over here, and salsa and so forth. Where's piano? There's piano, right? Okay. Just to make it a little bit clearer, so these are some contrasts between where saturation matters a whole lot, ska versus indie music, and Mozart versus dubstep, light to dark differences, and piano versus country, blue-yellow differences, and salsa versus Irish for red-green differences, okay? Now there's other stuff going on, right? I mean, salsa is red, and Ireland is pretty green, and at least is associated. So I'm not saying that all of this stuff is determined by emotion. There are other kinds of associations too. But there are, and we did a kind of multi-dimensional scaling, not Rogers' particular version, something that's called parafact scaling. But you get two affective dimensions for this, one of which is what we call arousal, which is agitated versus calm, and the other one is valence, which is happy versus sad. And you can see the colors that were picked for some of the extreme ones here. So piano is the piano piece that we played was this one. And this is telling us that this is sad, calm music, and it's paired with sad, calm colors. And salsa is agitated, happy music and colors. Now I'm going to just zip on by here. So what I'm going to show you now is just how much of this variance can be accounted for by emotion. All right. So these are low-level correlations between various perceptual dimensions, loud, punchy, dense, fast tempo, heavy, and so forth, musical dimensions, and the color perceptual dimensions of the colors people picked. And there's a lot of very significant color correlations here. They're the ones that are sort of in depth raised toward you, okay? Something, I think it's like 14 of these things. Now notice that blue-yellow, and this is sort of interesting, that when we did the classical music, the big variations were in blue-yellow because it was very much associated with valence, how happy versus sad does this music sound. Not so much on red versus green. Here we're getting almost nothing from blue versus yellow. And we're getting a fair amount from red versus green because agitation is coming in like a big factor in this kind of music. And so, okay. So now let's look at the emotional correlations. And those are the descriptors that we used over there. And again, we're getting an awful lot of correlations. interestingly, we're now finding blue-yellow correlations. It's correlating with happy, whimsical, and warm, which we were not getting when we were looking at the music association, the musical dimensions. So there's some variance that seems to be captured by the emotions that's not captured by the dimensions, at least the ones that we used. And the two groups that we talked about before, arousal and valence, seem to be represented here. Group 1A versus 1B is just the difference in polarity. One has spicy, loud, agitated, complex is loaded high on red, on saturation, and not on appealing, like, and harmonious, for example. But here's what I want to show you. So we're going to look at those correlations again. These are the correlations, 14 significant correlations between the music perceptual features and the colors that people picked. And now we're going to partial out the variance in that that is due to emotions. You can do this statistically, and in fact, you get no significant correlations. So all 14 of those significant correlations on the left disappeared after we partialed out the emotional variation. And you can do this again, even with just those two emotional dimensions of the multidimensional scaling, arousal and valence. And again, you get rid of all 14 of those significant correlations just by looking at those two emotional factors. The other way to look at this is to try to look at the extent to which you can predict people's color preferences from looking at the emotional versus the perceptual correlations. And these are the data that's showing the percentage of variance that you can explain using the arousal and valence emotional dimensions for each of the 4 color dimensions. You don't do quite as well with yellow, blue as you do with the others. But if you look at that, versus the 2 best fitting musical factors, we did a multidimensional scaling with the musical factors and took the 2 best ones. So we're looking at 2 dimensions versus 2 dimensions, so they're in some sense corresponding. And you don't do as well on any of the dimensions. And in fact, as I said, on yellow versus blue, you get none of the variance. Okay. If you increase that even to 8 musical dimensions, you still don't do as well as you do with 2 emotional dimensions. So I think this is pretty interesting evidence that, in fact, the associations, the goodness of fit between music and colors is in fact mediated by emotions in this particular way. It's a robust phenomenon, it's true for all kinds of different music, and I think it's sort of fundamental to understanding the relationships between preference, good fit, and emotion, in fact, in this case. I'm going to end by acknowledging my funding sources, whoever said we have to do that. But I'm going to surprise you here. So first I want to thank my collaborators and our sponsors, NSF primarily and Google secondarily. But we have one other important sponsor to thank, and that is Amy's natural frozen pizzas and vegetable dishes. And the reason is that when we started this project, we couldn't get NSF to fund this. I mean, they would have laughed us off the stage. But in fact, Karen's uncle worked for Amy's. And Amy gave us coupons for frozen Amy's pizza with which we paid our subjects. And that was the beginning of this monumental study. And finally, I want to thank you for your attention. Sorry I went over.
Any questions?
I wanted to add 3 items to this conversation. First of all, would there be a hard correlation between, well, what I was thinking of is color music synesthetes. They see particular colors for particular, for instance, deep purple is E flat minor, and it's consistent.
Yeah, we've actually looked at that.
So that's one thing I wanted to throw in.
It's never going to be published, but we've got data on that.
The the second two items are, I think we have to think these colors are very specific to our time and culture. I have a friend, Tuna Mac.
To our culture, certainly.
And to our time.
Yeah, could be.
I have reasons for that. But first of all, my friend Tuna McIntyre is from the Aleutian Islands. He's from the Yupik people. Tuna's color palette is black, white, blue, and red. Because there's nothing else. That's the environment he came from.
Right.
White for the snow, black for the night, red for the hunt, and a little bit of blue.
Uh-huh.
Either in beads that they traded or in the sky.
Yeah, sky
So
and water.
culturally,
Sure.
his idea of what constitutes color work.
Okay.
So that's another.
Cultural effects, yeah.
Third point, I think we have to think about the time that we're in and the lighting we use, because think back to the time when there was candlelight or when there was gaslight. The colors and fashions that people wore during the gaslight era would be too bright and too vivid for us now. It would be a completely different palette, saturated colors. Then as we move into electric light, our sensibility of color changes. Now we have fluorescent, we have LEDs, and the lighting, our lighting environment, at least in cities or interiors, I think really affects our perception of color, what we like and what we don't. I remember living in England and looking at their color chips in the hardware store. Vivid, gaslight related. Coming back to the West, a completely different palette was pleasing to Westerners than those who were living in northern Scotland.
Yeah, okay. There's lots of things to say about each of those things. Do I get equal time? I guess not.
Yeah. I mean, I just wanted to bring those up.
Well, I do have things to say about those things. But... So as far as synesthesia goes, we have done studies with synesthesia. I think Ram is probably going to talk about synesthesia in his talk, so we'll get some more about that. But we actually did the very same experiment with, they were timbre color synesthetes that were validated using the Baylor, what's his name? Eagleman, the Eagleman stuff. And what we found was very interesting. The main finding was that the colors that non-synesthetes picked to go with the music is actually very similar to the colors that synesthetes report experiencing to the same music. The difference is, and there are big emotional effects in the synesthetes data, which discriminates to some degree between some different kinds of theories of synesthesia. If anything, though, there was less of a correlation with the emotional stuff for the synesthetes than for the non-synesthetes. It's almost as though for the synesthetes, what they've got are the emotional associations, and the synesthetes have something else in addition, which might be cross-wiring and much more idiosyncratic kinds of things. So it won't be ever published because I won't go into that. But the second thing about culture is, yes, absolutely, we have studied color preferences across different cultures, and we do find substantial differences in different cultures. We actually, we did this initial music color association experiment both in Berkeley and in Mexico, which maybe isn't the biggest difference in culture that you could find, but in fact the data looked like Xerox copies in Mexico to what we found in Berkeley. We started a project in where was it? I'm blanking. It's in the Middle East with music that was much more different from Western music, but it didn't get off the ground because revolutions happened. And as far as different times, I mean, there I'd say, you know, I didn't really think of doing that because not many people, you know, doing it in candlelight versus not candlelight. If color constancy is pretty good, then differences in lighting shouldn't matter too much. But there are, you know, pretty radical differences in lighting that probably would make some difference. But still, I think, like for the music color associations, I think that those things would be pretty similar. It's not that under different lighting conditions, all of a sudden, you're going to see people picking dark colors for the happy music and so forth. Okay.
One very quick question. I wanted to ask about the dimensions that you were using for judging music and emotion, because I noticed you used the minor major dichotomy as well as tempo, which in the literature are certainly two factors that we know influence emotion in music. But with the examples you played, the most striking difference is timbre.
Is what?
Is timbre.
Timbre,
And
yeah.
we also know, there's a delightful little study by Mike Schutz up at the McMaster Institute, which shows that he compared xylophone and marimba music. And you cannot make a xylophone sound sad. You can have it play the same exact music, minor mode, slow tempo as a marimba piece, and people just do not hear it emotionally the same way. And you also think about sort of the language we use to describe timbre also seems to evoke a lot of color, emotional, you know, warm, bright. I think of the salsa example. I looked at those colors and went, of course, it's brass, it's percussion. It's going to be the sort of bright, warm colors because of the temporal composition. So I'm wondering if you've looked at all into timbre as another dimension within this sort of correlation between sort of musical dimensions and color and affect.
Yeah, we did not look at timbre, and the reason is pretty simple, which is that whereas a lot of these other dimensions are pretty easy to quantify, it was not at all clear how to talk about, I mean, there are multidimensional scaling models of timbre, but they're not very intuitive. And as far as laying out a set of experiments, we decided we'd do the things that were the low-hanging fruit first. We did some experiments that were on people's associations, or people's goodness of fit ratings between textures and music.
Sure.
Okay, and there are systematic effects there too, but once again, they differ from the color ones because think about what textures are happy versus what textures are sad. There's not much there. Mm-hmm. And so that kind of, but agitation or, you know, arousal was huge in those things. So you got textures that were like crazy, you know, random, dark, angry textures. You know, people picked the angry looking colors. So we have done some other things, but we never have made it to texture for that reason.
Okay.
I have
One more.
it should be brief with both of those. So I
You
noticed
never know when you ask me a question what's going to be brief.
So in your color preference stuff you talked about earlier, where you had the really good match between the words. Anyway, there was a mismatch with the dark red. Everything else had perfect matching, but the dark red was much,
wasn't as positive.
Yeah.
Yeah, I don't know why.
Okay.
I don't know why. And I would just say as a final thing, I didn't even say the final conclusion of what I hope is a take-home message of the talk, which is that aesthetic science is possible. It's actually pretty cool, and you can get really powerful effects if you study it in the right way, and I wish more people were doing it. I'm kind of done with it because I'm now an artist. I'm doing it in a whole different way.
Well, I'll encourage you to approach Stephen during lunch or break this afternoon with more questions. Right now, I think we're going to take a break for lunch. Lunch is served in the cloisters, which is across the courtyard and to